Good morning everyone. Welcome to the next lecture. Today we will discuss about one of the most important application of a matrix, that is to give solution to the system of linear equation. See, in this lecture we will discuss how to solve the system of linear equation with the two or three variables by using matrix inversion method. So thus, to solve the system of linear equation, we must need the mastery over the inverse of matrix, which we were already discussed in the last lecture. So let's see how to solve the linear equation by using the method of inverse of matrix. See here, the solving the system of linear equation using the inverse of matrix, which require the definition of three different matrices. See, the first one is, here it is matrix A, which is nothing but, which is popularly known as, it is coefficient matrix, which is the coefficient matrix which represents the coefficient of the variables in the system of linear equation. So it is the coefficient of the each and every variables which is given in the system of linear equation, which is generally denoted in terms of A. So after finding the coefficient matrix, the secondly we want to find the X matrix. That means it is the variable matrix, which is the matrix which representing the variables of the given system of linear equation. What are the various variables are given here, and we are forming a particular matrix which is generally known as, it is X matrix, which is considered as a variable matrix. See, after that finally we have a B matrix, or which is generally known as, it is a constant matrix, which represents that the constants which are on the right side of the equation. What are the various constants which are given in the right side of the linear equation, which will become the part of elements of the constant matrix. So using the matrix multiplication, we can define the system of equation with the same number of equation as the variable we have. So as which is known as, we can say that it is Ax is equal to B. By combining these three matrices, see, we can say that it is Ax is equal to B, where A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. So if you go for multiply the both side by the inverse of matrix, if you go for multiply the inverse of matrix in the both side of this equation, then it will become the inverse into A into X, which is equal to the inverse into B. See here, inverse into A, that is original matrix. If you go for taking the product of original matrix with its inverse, then it will provide an identity matrix, which we are already proved in the last lecture while we were discussing about the inverse of matrix. Because one of the important property of an inverse of matrix, that is, if you go for taking the product of original matrix with its inverse, it will produce an identity matrix. So instead of A inverse into A, here I am writing the only identity matrix. So identity matrix into X, then inverse into B. It is inverse into B. So it means that, see here, I can say that if you go for multiplying the identity matrix with the variable matrix, then we can say that it will produce the same thing, or it will be unchanged. So the identity matrix, because if you go for multiplying any matrix by using an identity matrix of appropriate size, then it will leave the matrix unaltered or unchanged. So we can say that we can simply write the product of identity matrix with the variable matrix, it will produce a variable matrix itself. So the X is equal to, inverse of matrix into B, that is constant matrix. So it means that we can find the value of variables, that is X. In terms of X, for example, we have a three variable, consider X, Y, Z in the given matrix, X matrix, by multiplying the inverse of a matrix A by the constant matrix, that is B, which is the constant matrix. So thus, to find the value of unknown variables of a given linear equation, first we have to find the inverse of matrix, and after that you have to go for multiplying the constant matrix with the inverse of matrix, so that you will get the value for the system of linear equation, or it is the value for the each and every variable which are included in the system of linear equation. So we can say that if Ax is equal to B, then x is equal to the inverse into the constant matrix, that is B. So now we can find the solution for a system of linear equation by using the matrix inversion method. See, consider we have two equations here, simultaneous equation is given, that is 18x minus y which is equal to 87 minus 2x plus 36y which is equal to 98. Now we are going to write this particular system of linear equation in the form of Ax is equal to B. We know what actually mean by the A, which is the coefficient of the each variable. We are going to frame a particular matrix by considering only the coefficients of the variable. So here coefficients of the variable are 18, minus 1, minus 2 and 36, which we are writing here, and x is the variable matrix. So here we have two variables are here, that is x and y. So I am multiplying, it is x, y, we have a variable matrix which is equal to B. What is B? It is the constant which is given on the right side of the each equation, that is 87 and 98. So we are written the given linear system of linear equation in the form of Ax is equal to B. After writing this particular form, we have to find the determinant of a given matrix, because in order to find the solution to the system of linear equation, first we have to find the inverse of matrix. So here we are going to find the determinant of a given value of a matrix. So it is 18, minus 1, minus 2 and 36 is the matrix A. So we are going to find the determinant of this given matrix, which is equal to 18 into 36 minus 2 into 1, or minus 1 into minus 2. So if you go for simplify it, then it is 18 into 36 which is equal to 648 minus 1 into minus 2 which is equal to 2. So it is 648 minus 2 which is equal to 646. See, after finding the determinant value, our next step is to find the minors. See, what are the minors here? The minor of 18, by crossing the concerned column and the row, what is remaining here? It is 36. Then what is the minor of minus 1? By crossing the first row and the second column, it is minus 2. Similarly, the third minor, that is minor of minus 2, which is equal to crossing the first column and the second row, then it is equal to minus 1. And the fourth minor, which is equal to, see, crossing the second column and the second row, it will be, what is remaining here, it is 18. So our minors are here, it is 36, minus 2, minus 1 and 18. See, after finding the minors, our next step is to find the cofactors. So I am writing here the various minors, minus 36, minus 2, minus 1 and 18. See, after that we have to find the cofactors of a given matrix. So here the cofactors are C11, which is equal to minus 1 raised to the power 1 plus 1 into the first minor, which is equal to 36. So it will be minus 1 square, which is equal to 1 into 36. 1 into 36 is equal to 36. Similarly, we have a cofactor second, which is equal to minus 1 raised to the power 1 plus 2 into the second minor, which is equal to minus 2. So we have a minus 1 cube, so it is a minus 1 here, minus 1 into minus 2, which is equal to 2. Then the third cofactor, that is C21, which is equal to minus 1 raised to the power 2 plus 1 into the M21, which is equal to minus 1. So minus 1 cube, which is equal to minus 1 into minus 1, which is equal to 1. Fourthly, we have a cofactor C22, that is minus 1 raised to the power 2 plus 2, which is equal to minus 1 raised to the power 4 into the fourth minor, which is equal to 18. So minus 1 raised to the power 4, which is equal to 1 into 18, which is equal to 18. So these are the various cofactors of a given matrix, that is 36, 2, 1 and 18. After finding the cofactors, you know how to find the cofactor matrix. We are going to replace the each and every element of a given matrix by using its cofactor element. It will become C36, 2, 1, 18. So this is the cofactor matrix. See, after finding the cofactor matrix, the next step is to find the adjoint of a matrix. You know how to find the adjoint of a matrix? If you go for taking the transpose of a cofactor matrix, then it will become the adjoint. So here we are going to interchange row into column and columns into rows. So it will become, see here, the adjoint A is equal to the transpose of a cofactor matrix, which is equal to the first row, that is 36, 2, which will become the first column here. The second row, that is 118, it will become the second column here, that is 1 and 18. So this is the adjoint of a matrix A. See, after finding the adjoint of a matrix, then the next step is to apply the formula for finding the inverse of matrix. See, inverse of matrix we can find, that is 1 by the determinant value of A into the adjoint A. So here we are already estimated the determinant value, which is equal to 646, and the adjoint is here 36, 1, 2, 18. If you go for multiplying 1 by 646 with each and every element of an adjoint A, then you will get the inverse of matrix. It is equal to, see, by dividing and simplifying, 36 divided by 646 we can write it is 18 divided by 323. Then here 1 divided by 646. Then we have 2 divided by 646, simplify, we can write it is 1 divided by 323. Then 18 divided by 646, we can write it is 9 divided by 323. So this is the inverse of matrix. See, after finding the inverse of matrix, we actually want to find the value of the each and every variables which is given in the original matrix. So here, in order to find the each and every value for unknown variables, we are going to multiply the inverse of matrix with its constant matrix, which is equal to B. So here, we are going to use the equation, that is x is equal to, that is the variable, unknown variable value is equal to inverse into the constant B, that is constant matrix. So here the inverse of matrix we are already found here, that is 18 divided by 323, 1 divided by 646, 1 divided by 323, 9 divided by 323 into B, that is constant matrix, which is already given there, that is 87 and 98. Now see, we can go for multiplying these two. We have a 2 by 2 matrix and we have a 2 by 1 matrix. So of course the multiplication is possible, and if you go for multiplying it, it will produce a 2 by 1 matrix again. So if you go for multiplying it, see, we can multiply the first row with the first column here. So if you go for multiplying and simplifying it, then it will become 1615 divided by 323. Similarly, if you go for multiplying the second row with this particular column, then it will become 969 divided by 323. So if you go for simplifying by dividing these two terms, then it will become, see, 1615 divided by 323, which is equal to 5, 969 divided by 323, which is equal to 3. See, what is these values represent? This is nothing but this is the values for the unknown variables, that is x and y. So here x is the first element and y is the second element. So here x is equal to 5 and y is equal to 3. So in this way, we can find the solution to the system of linear equation by using the inverse of a matrix. Now consider another example. Solve the linear equation by using the metric inversion method. See, we have a system of linear equation here. We have 3 equations are here and 3 unknown variables are also here, that is x, y and z. See, now we are going to write this particular equation, that is in the form of Ax is equal to B. So here A is the coefficient matrix. So what are the various coefficients here? That is 5, minus 2, 3. 2, 3, minus 5, 4, minus 5 and 6. I am going to write it as separate matrix, which is known as, it is matrix A, into the x, which is the variable matrix, which is here x, y, z. We have 3 variables, that is x, y, z, which is equal to the B, that is constant matrix, which is the element which is given in the right side of the equation, that is 16, 2 and 7. So we are written the equation in the form of Ax is equal to B format. So this is the result. Now we are going to find the inverse of matrix first. So in order to find the inverse of matrix, first we have to find the determinant value of given matrix A. So here the matrix A is equal to here 5, minus 2, 3, 5, 2, 3, minus 5, 4, minus 5 and 6. See, we want to find out the determinant value of this given matrix. So first we are going to find the determinant value by taking the first element, that is 5, and accordingly we are going to cross the first row and the first column. Then it is equal to 5 into 3 into 6 minus 5 into minus 5 minus second element, that is minus 2 into crossing the second column and the first row. We have a 2 into 6 minus 5 into 4 plus the third element, that is 3 into crossing the concerned row and the column. Then it will be 2 into minus 5 minus 3 into 4. So if you go for simplifying it, then it is 5 into 3 into 6, which is equal to 18, minus 5 into minus 5, which is equal to plus 5. So sorry, which is equal to plus 25. So here already minus here. So we can say that it is 18 minus 25 plus minus 2, that is equal to plus 2 into 2 into 6, which is equal to 12, minus 5 into 4, which is equal to 20, plus 3 into 2 into minus 5, which is equal to minus 10, minus 3 into 4, which is equal to 12. So it will become a minus 12. So if you take the difference between these two values, then it will become 18 minus 25, which is equal to minus 7, 12 plus 20, which is equal to 32, then minus 10 minus 12, which is equal to minus 22. If you go for multiplying these terms, it is equal to minus 35 plus 64 minus 66, which is equal to minus 37. So minus 37 is the determinant value of given matrix. See, after finding the determinant value of a given matrix, the next step is to find the minors of a given matrix. So what are the minors here? See, M11, which is equal to taking the first element and crossing the concerned row and column. See, it is 3 into 6 minus 5 into minus 5, which is equal to 18 minus 5, 25, which is equal to minus 7. Similarly, the second minor, considering the second element and crossing the concerned column and the row, then we have a 2 into 6 minus 5 into 4, which is equal to 12 plus 20, which is equal to 32. Similarly, we can find the third minor, that is equal to crossing the first row and the third column, then it is 2 into minus 5 minus 3 into 4, which is equal to minus 10 minus 12, which is equal to minus 22. Accordingly, we can find the remaining minors. See, we have a 9 minors here. We have a M21, which is equal to 3, M22, which is equal to 18, M23, which is equal to minus 17, M31, which is equal to 1, M32, which is equal to minus 31, and M33, which is equal to 19. See here, we found the minors for the each and every element of a given matrix. See, I am writing here separately the minors so that it will be very easy. See, after finding the minors, I am writing here the minors here, and after finding minors, we want to find the cofactors for the given matrix. See, what are the various cofactors for the each and corresponding minors? We have a C11, which is equal to minus 1 raised to the power 1 plus 1. So it will become minus 1 square into the M11, which is equal to minus 1. So it is minus 1 square, which is equal to 1 into minus 7, which is minus 7. Similarly, we can find the second cofactor, that is C12, which is equal to minus 1 raised to the power 1 plus 2, which is equal to minus 1 cube, which is minus 1, into the minor, which is equal to 32. So minus 1 into 32, which is equal to minus 32. Similarly, we can find the third cofactor, that is C13, that is minus 1 raised to the power 1 plus 3 into the third minor, which is equal to minus 22. So we have a minus 1 raised to the power 1 plus 3, which is equal to raised to the power 4. So it is equal to 1 into minus 22, which is equal to minus 22. Accordingly, you can find the remaining cofactors. Of course, we have a 9 minors, so for we have the 9 cofactors as well. So C21, which is equal to minus 3, C22, which is equal to 18, C23, which is 17, then C31, which is 1, C32, which is equal to 31, and C33, which is equal to 19. So after finding the cofactors, I am writing here the cofactors separately so that it will be more easy for introducing the calculations in a new sheet. So here, this is the cofactors. See, after finding the cofactors, what is our next step? We have to frame the cofactor matrix. How to find the cofactor matrix? We are going to replace each and every element given in the original matrix with its cofactor elements. So the cofactor elements here, that is minus 7, minus 32, minus 22, minus 3, 18, 17, 1, 31 and 19. See, this is the cofactor matrix. See, after finding the cofactor matrix, we have to find the adjoint of a given matrix. How to find the adjoint? See, the adjoint can be found by taking the transpose of a cofactor matrix. So here we are going to interchange the rows into columns and columns into rows. So it will become, see here, the first row will become the first column here, the second row will become the second column here, and the third row will become the third column here. So accordingly, we will get the adjoint of a matrix, which is nothing but it is the cofactor matrix. So the adjoint of a matrix is here minus 7, minus 3, 1, minus 32, 18, 31, minus 22, 17 and 19. So this is the adjoint of a matrix. See, after finding the adjoint of a matrix, what is our next plan? We want to calculate the inverse of matrix. So we are just applying the formula for calculating the inverse of matrix, which is equal to 1 by the determinant value of given matrix A into the adjoint A. So already we are calculated the determinant value and adjoint A, then it is equal to 1 by minus 37. Minus 37 is the determinant value of the original matrix. Then we have an adjoint, that is minus 7, minus 3, 1, minus 32, 18, 31, minus 22, 17 and 19. So now we can multiply 1 by minus 37 with each and every element in the given matrix. So it will be simply a scalar multiplication. So it is equal to, see, minus 7 divided by minus 37, which is equal to minus will be cancelled out. So it is 7 divided by 37. Minus 3 divided by minus 37, which is equal to 3 divided by 37. 1 divided by minus 37. Then minus 32 divided by minus 37, which will become 32 divided by 37. Then 18 divided by minus 37. 31 divided by minus 37. Then minus 22 divided by minus 37, which is equal to 22 divided by 37, 17 divided by minus 37 and 19 divided by minus 37. See, this is our inverse of matrix. This is the inverse of matrix. See, after finding the inverse of matrix, what we want to do? We want to find out the value for the unknown variable by multiplying the constant matrix with its inverse of matrix. So here, it is equal to, that is the unknown variable x is equal to the inverse of matrix into the constant matrix, which is equal to b. So here the inverse we are already estimated, that is 7 divided by 37, 3 divided by 37, 1 divided by minus 37, 32 divided by 37, 18 divided by minus 37, 31 divided by minus 37, 22 divided by 37, 12 divided by minus 37 and 9 divided by minus 37. We are going to multiply this inverse of matrix with the constant matrix, that is 16, 2 and 7. So this is the B. So of course we can multiply these matrices because it is one is 3 by 3 matrix order and another one is we have a 3 by 1 matrix. So if you equate it, then we can, of course, the multiplication is possible and it will produce a 3 by 1 matrix. So if you go for multiply it, then see, we are going to multiply the first row with the first column, this column, then the second row with this particular column, and the third row with this particular column. Then it will give the 3, 7 and 5. If you go for simplifying it, its value will be 3, 7 and 5. What is this particular values represent or these elements represent? It is the value for the unknown variables of x, y, z. So here x is equal to the first element, which is 3, and y is equal to 7, which is the second element, and the third element 5, which is z. So z is equal to 5. So our values of unknown variable for the system of linear equation that are x is equal to 3, y is equal to 7 and z is equal to 5. So let us consider the another example, especially in the application level. See, we have a given question, that is IS equation is given. That is ISLM model we are going to explain here. So here the IS equation is given, that is 0.3y plus 100i, which is equal to 252. Similarly, the LM equation is also given, that is 0.25y minus 200i, which is equal to 176. See, what we want to find out here, we want to find out the y and I, because we have a system of linear equation here. See, we have a two equation here and we have a two unknown variables as well. What are the unknown variable here? It is y and I, that is level of income and the rate of interest. So accordingly, from this particular problem, we want to find out the equilibrium level of national income and the rate of interest. So we have a system of linear equation with the two unknown variables are here, that is y and I. So the first step, by using the matrix inversion method, we can solve this particular example. See, the first step is here, that is we want to write this particular system of linear equation in the form of Ax is equal to b. See here, Ax is equal to b, where A is the coefficient of the given variable, that is my 0.3, 100, 0.25 and minus 200, into x variables. Here the variables are y and I. So I am putting here in the bracket, that is y and I. then which is equal to the constant, that is B matrix, which is equal to 252 and 176. So we have a AX is equal to B format. So we can find the first one, that is how to find the determinant of given matrix A. So the determinant of this given matrix, which is equal to 0.3 into minus 200 minus 100 into 0.25, which is equal to, if you go for simplifying it, which is equal to minus 85. So minus 85 is the determinant value of given matrix. See, after finding the determinant value, what is the next step? We want to find the minus. See, the minor of first element, that is 0.3, by crossing the first column and row, which is equal to minus 200. Then the second minor, that is minor of 100, by crossing the first row and the second column, what is remaining here? It is 0.25. The third minor, that is M21, so it is the minor for the 0.25. So we are crossing the first column and the second row, which is equal to, what is remaining here? It is 100. Similarly, the fourth minor, that is we are going to cross the second row and the second column, which is remaining 0.3 here. So the minors are minus 200, 0.25, then 100 and 3. See, after finding the minors, the next step is to find the cofactors for the each and every element. See, cofactors are C11, which is equal to minus 1 raised to the power 1 plus 1 into the minor, which is equal to minus 200 here. So minus 1 square, which is equal to 1 into minus 200, which is equal to minus 200. Similarly, the second cofactor, that is C12, which is equal to minus 1 raised to the power 1 plus 2 into the second minor, which is equal to 0.25. So minus 1 cube, which is equal to minus 1 into 0.25, which is equal to, again come out with 0.25. See, the third cofactor, that is C21, that is minus 1 raised to the power 2 plus 1 into the third minor, which is equal to 100. So minus 1 cube, which is equal to minus 1 into 100, which is equal to minus 100. The fourth cofactor, that is C22, that is minus 1 raised to the power 2 plus 2 into the fourth minor, which is equal to 0.3. So it is minus 1 raised to the power 4, which is equal to 1 into the fourth minor, which is equal to 0.3. So if you multiply these two, which is equal to 0.3. See, we found the minors and the cofactors. I am writing the cofactors separately here. See, after finding the cofactor, the next step is to find the cofactor matrix. You know, the cofactor matrix, we are going to replace the each and every element of the original matrix by using the cofactors. So here the cofactor elements are minus 200, 0.25, minus 100 and 0.3. So this is the cofactor. See, after getting the cofactor matrix, you know, we are going to take the transpose of cofactor matrix so that we can find the adjoint of a given matrix. See, the adjoint is equal to, it is the transpose of a cofactor matrix. So here the transpose of a cofactor matrix, we are going to interchange the first row into column and the second row into the second column. So it will become, see, minus 200 minus 100, 0.25 and 0.3. So here, see, we have the adjoint of a matrix, which is the cofactor, the transpose of a cofactor matrix. So we have minus 200, minus 100, 0.25 and 0.3. See, after finding the adjoint of a matrix, we are going to apply the formula for calculating the inverse of matrix. What is the inverse of matrix? We can find the inverse of matrix by using the formula, that is 1 by the determinant value of A into the adjoint. So we are already calculated the determinant value and adjoint. We are just going to substitute here. Then the determinant value is equal to minus 85 and the adjoint, which we are estimated here, it is minus 200, minus 100, 0.25 and 0.3. So if you go for multiply 1 by minus 85 with each and every element of a given matrix, then it will become, see, minus 200 divided by minus 85, which is equal to, simplifying it, it will become 40 divided by 17, then minus 100 divided by minus 85, which is equal to 20 divided by 17. Then similarly, we have 25.25 divided by minus 85, which will become, see, 0.05 divided by 17 minus, then it is 0.3 divided by minus 85, which is equal to minus 0.06 divided by 17. So this is the inverse of matrix. See, after getting the inverse of matrix, we are going to multiply with the constant matrix B. So it is so that we will get the value for the unknown variable. So x is equal to, it is inverse into the constant matrix, which is equal to B. So the inverse we are already estimated here, and we are going to multiply with the constant matrix, which is 252 and 176. So we have a 2 by 2 matrix and we have a 2 by 1 matrix. Of course, multiplication is possible, and if you go for multiplying it, it will produce a 2 by 1 matrix. So if you go for multiplying it, then it will produce, it is equal to 800 and 0.12. See what actually this 800.12 showing, it is nothing but it is the equilibrium level of national income, that is Y, which is equal to 800, which is the national income, and the 0.12, which is representing the rate of interest, which is equal to I, that is the rate of interest, equilibrium level of rate of interest, which is equal to 0.12. So as per the ISLM model, which is actually showing that it is the various combinations of, the equilibrium level of the income and the rate of interest. So here the equilibrium level of income is equal to 800 and the equilibrium level of rate of interest is equal to 0.12. So we can conclude here. Today we have discussed one of the most important application of metrics is to find the solution to the system of linear equations. So by using the method of inverse of matrix, we solved the system of linear equation by taking 2 by 2 matrix as well as 3 by 3 matrix along with some of the applications level questions. I hope it was clear to you, and in the next lecture we will discuss the Cramer's rule for solving the system of linear equation. So we will see in the next lecture. Thank you.